Hello, everyone. I'm Olympia. Thank you for being here with me in this wonderful place called Lights Out Library. And I have a great story to tell you. It's time to take a deep, calming breath because I'm going to begin tonight's story by taking you on an accelerated journey through time, from the creation of the Earth to the period we will explore this evening, the Pleistocene epoch, also known as the Ice Age. As always, you do not need to watch the video to follow along. If you wish to, you may close your eyes and forget about any worries as we embark on this adventure together. Also, we just launched a Patreon page for those of you who wish to support this project and get more of it. If you join, you will get various new things like the possibility to listen to all episodes with background sounds or without. Regular bonus episodes. There are already 2 exclusive stories for our Patreons available: The History of Glass and Stained Glass, and the story about the mysterious man in the iron mask. You will be able to download all of these audios, and you will also have your say on the choice of topics, advanced releases, and updates on upcoming episodes. We hope to see you there soon so that we may continue developing Lights Out Library, which we enjoy so much. You will find links in the description box and the first comment pinned under the video. If you fall asleep and wish to resume the video later or jump directly to a particular part of the story, timestamps are also listed in the description and pinned in the first comment, as well as links to different streaming options like Spotify, Apple Podcasts, and Amazon Music, which may be better suited for you. But before we dive into all of this, assume a comfortable position. Take a long, deep, relaxing breath, and when you exhale, release the tension in your shoulders, your neck. Release the tension in your facial muscles too, and allow the sound of my voice to guide you through this journey. This journey begins 4.5 billion years ago. In our small corner of the galaxy, planet Earth, like billions of other planets before it, began to form around a young star, our future sun. In the beginning, this young planet was really just a ball of liquid metal, its surface made of molten rock, rivers of lava, and volcanoes. Its geography changed quickly as it was intensely bombarded by asteroids of all sizes, and the planet acquired an internal structure and changed its appearance as a result. Its atmosphere was made of toxic gases and contained almost no traces of oxygen. No conceivable life form could exist in such a hellish environment. This was the Hadean Eon, the first age of Earth. But even though the Hadean lasted for 500 million years, it finally did come to an end 4 billion years ago when the bombardment slowed down and the planet's crust grew thicker and thicker, solidifying as the planet cooled. This primordial hell became a little quieter, and the new eon began, the Archean. The continents had formed, and they were very different in their appearance and location than they are today. Between them lay oceans of liquid water, but there was still almost no oxygen in the atmosphere, and the land was barren. There were no plants, no animals to be found anywhere on land, no witnesses to the intense volcanic activity or to the earthquakes that caused mountain chains to rise tens of thousands of feet toward the stars. This eon lasted for an inconceivable 1.5 billion years, 3 times longer than the Hadean. But something else had happened on Earth in the meantime. In shallow waters near the continent's wall, where the ocean floor was close to the surface, life had appeared. Nothing spectacular yet, just mats of organisms forming colonies. But with these microorganisms appeared a new phenomenon. They could convert the sun's light energy into chemical energy, making their life possible. This phenomenon, photosynthesis, produced oxygen as a byproduct. But still, for hundreds of millions of years, the vast oceans of Earth absorbed this oxygen, and the atmosphere stayed oxygen-free. But at some point, the water became saturated, and the excess oxygen began to escape into the atmosphere. After 1.5 billion years, the Archean eon was reaching its end, and a new age was about to begin, one even longer that would last for 2 billion years. The name that humans gave to this new eon, in which oxygen started to appear in Earth's atmosphere, is a Proterozoic, meaning earlier or former life. During this age, a new miracle happened. Life forms up until then had been single cells, but now multicellular organisms had begun to form and multiply. Maybe these organisms had appeared sooner, during the Archean, but their numbers grew exponentially during the Proterozoic. Though still very small, the multi-celled organisms were several times bigger than the more primitive organisms in which they now coexisted, and they had the effect of changing the chemical composition of the planet. Oxygen was now freely escaping the oceans and accumulating in the atmosphere. Many things continued to happen at the surface of the planet during these 2 billion years. Continents kept drifting, and the Earth's appearance continued to change. The climate changed multiple times and at various points. The Earth may have been entirely frozen, resembling a snowball traveling through space. There were still no plants or animals on land, but in the seas. As the end of the Proterozoic eon neared, the first soft-bodied animals began to colonize the oceans. We are now 550 million years in the past. We have already covered almost 90% of Earth's lifespan, and a new era was about to begin. The Phanerozoic, our era, an age of abundant animal and plant life on Earth. Abundant, to be sure, but with many ups and downs due to a constant changing planet and climate. Life radiated and grew exponentially. The first species of animals able to survive out of the water started walking on continents. Different plants covered the land and formed forests that could prosper in our oxygen-rich atmosphere. But also, multiple times after millions and millions of years, the development of life and a new species that had appeared were upset by catastrophic events, intense volcanic activity, changes in climate patterns, collisions with asteroids, and whenever this happened, life on Earth experienced big setbacks, and many species went extinct. Still, the Earth, despite its profound losses, recovered time and again from extinction events. These phases of expansion that ended abruptly are their own eras that are themselves cut into shorter periods that experienced more limited extinctions. We call these periods Cambrian Ordovician, Carboniferous, Triassic, Jurassic, Cretaceous. 12 in total have been identified and named as segments within the Phanerozoic, and they are themselves composed of shorter epochs because they still lasted millions of years. Various events and changes were observed within these long periods. Finally, 2.6 million years ago, just yesterday really on the scale of the 4.5 billion years we have just covered, one of these periods, called the Neogene, ended in glaciation. A new period, called the Quaternary. This is the period we will focus on tonight, the first epoch of the Quaternary. The Pleistocene epoch is also called the Ice Age because it was characterized by various glaciations, by expansions and withdrawals of ice sheets over the continents. But it was still an age of abundant life and the rapid evolution of species, including our own genus, Homo, which became arguably the most successful at colonizing the Earth. This ice age took place less than 12,000 years ago in a new epoch of relative heating, the Holocene, the era in which we live now. Tonight, we will explore what the planet was like during the Ice Age, who and what lived through it, or at least what we know or can observe and deduce about it. There will be mammoths and saber-toothed tigers, of course. But what animals walked the earth and lived in the seas? I will tell you about the rise and diversification of the genus Homo, of ancient humans, and about the evolution of our species. This is a field of investigation that is continually evolving, along with our understanding of the past, and there have been many new discoveries and theories in recent decades. So bear in mind that the state of scientific consensus could and probably will keep changing. Most of what we're going to learn about tonight is not a definitive truth, but rather theories that are informed and supported by paleontology, archaeology, geology, climate science, and reasoning. But still, all those fields of study can mostly only speculate about the evidence on hand. There is no instant replay or eyewitness statements on which they can rely on. So, like them, tonight we seek to better understand the Ice Age while knowing the limits of our own understanding. Let's begin our story with a question. What did our planet look like during the Ice Age? 2.5 million years ago, a map of Earth's continents would have actually looked familiar to modern humans. Over tens or hundreds of millions of years, land masses can change dramatically because continents have time to drift apart or to collide. And they can travel thousands of miles. But 2 or 3 million years is not that much on a geological scale, and so the continents during the Ice Age were already nearly where they are today. and I will reference locations based on modern geography. However, a closer look would reveal several small differences. First, during the multiple glaciations that happened in cycles over tens of thousands of years ago, which we will discuss more later, ice sheets near the poles extended much farther than they do today. For example, in North America, all of Canada was sometimes under ice, and polar ice also covered the northern parts of the United States. Cities like Boston, New York, Chicago, Seattle would have sometimes been under ice, as were much of Siberia and western Russia on the other side of the North Pole. At peak coverage, it is estimated that about 30% of the Earth's surface was encased in ice, hence the name Ice Age. Still, during this period, tropical and equatorial regions did have much warmer climate. The implication of all of this water being locked up in ice was that many of today's islands were at the time connected to continents by land. Various straits did not exist, and overall, there was more land surface than we have now. On several occasions, North America and Asia were connected by land around the Bering Strait, allowing animals and humans to cross. Another major change that occurred just as the Pleistocene began was that North and South America became connected via the Isthmus of Panama. Prior to that, the Atlantic and Pacific Oceans met at this point, separating North and South America by ocean. This new land connection between the two continents had dramatic consequences. South America had been a gigantic island for millions of years, developing its own terrestrial species that, though they could have had ancient connections with species of other continents, had evolved separately for a very long time. This new land bridge allowed an exchange of species between the two Americas. The connection probably also had a dramatic impact on the climate because it was cut off a major passage between the two largest oceans of the planet. And this changed oceanic circulation with impacts on temperature, winds, and currents. Apart from continental glaciers, glaciation also sustained a cold climate near the edges of the glacial sheet. In North America, southward from the edge of the ice, there was a permafrost zone that extended a few hundred miles. That is to say, the ground in this zone remained continually frozen below 0 degrees Celsius. In Eurasia, Siberia for the most part, the permafrost was even larger. These permafrost regions can be precious for scientists because the frozen earth can keep entire, intact specimens of extinct species frozen for thousands of years, or even tens of thousands of years, provided the area doesn't warm up. This is how specimens of extinct species that are very well preserved, like mammoths and more recently a bear and a wolf, have been found and studied. Also south of the ice sheets, large lakes accumulated when the deep gouges left by retreating ice sheets then filled with ice melt. For example, this happened on a large scale in central North America with the creation of a disappeared lake called Lake Agassiz, northwest of the Great Lakes in the middle of Canada. This glacial lake, created by the melting of glaciers, was larger than the United Kingdom, or almost twice as large as Florida. It appeared at the very end of the Ice Age and is thought to have lasted only a few thousand years, until draining and evaporation left only small lakes behind. The geography of Canada and Finland, with their abundance of lakes, still bears the traces of this period. But how many of these glaciations were there and why? This is where the study of glaciers and polar caps provides interesting information, because variations in the composition of the atmosphere, like the amount of carbon dioxide and other gases, leave traces in the various layers of accumulated ice, which is where we can measure them. Study of these variations suggests that significant advances of the ice sheet, these glaciation periods, happened at intervals of approximately 40,000 to 100,000 years. In between the long glacial periods, there were shorter periods of 10 to 15,000 years. In between the long glacial periods, there were shorter periods of 10 to 15,000 years, when the climate was closer to what we expect today. These phases that repeated cyclically each had a huge impact on land and marine species and their habitats. Glaciation did not always lead to automatic extinction, but instead to migration away from the advancing continental glaciers and frozen seas, in search of warmer regions where the food could be found. But what caused these cycles of cooling and warming? It is believed that they were due to the cyclicality of climate factors at the Earth's surface. Climate, ocean currents, wind currents, temperature, and other movements follow cycles. These cycles are influenced by many factors: by the composition of the atmosphere, the motion of the planet, and its obliquity, also known as its axial tilt, which means small changes in the angle of the Earth's axis. There is also the intensity of solar radiation that varies over time, and eventually, as these multiple cycles collide and align, they converge to produce a dramatic shift in the climate. These cycles can exist for long periods of time, but they are not eternal. Each repetition includes small variations, which introduces elements of instability that can change the climate over time. For example, a pattern change was observed during the Ice Age by the middle of it. Prior to the pattern change, the periodicity of glaciations was about 40,000 years. But a climate transition happened that changed the periodicity to 100,000 years, but with more intense, more powerful cooling. A climate variation like this naturally happened had an impact on all living beings, on plants too, and that included humans, who emerged as an increasingly dominant and adaptable species during this period. So, which other species adapted best to the Ice Age? What was the fauna like? Some animals from this period are famous, like the mammoth or the smaller saber-toothed tiger, but these are just a couple of iconic animals among thousands and thousands of species, many of which still exist. Let's take a look at the kinds of animals we could have encountered during the Ice Age. A phenomenon that started millions of years earlier, the domination of land mammals, was confirmed during the Ice Age. This domination began long before the Pleistocene. Paleontology dates it from the extinction of non-avian dinosaurs at the end of the Cretaceous, 66 million years ago. We know that birds are classified as dinosaurs because they share the same branch in the evolutionary tree. However different a T-Rex and a sparrow might look, they have a single common ancestor. This is why dinosaurs are technically not extinct, but all non-avian dinosaurs, land-dwelling dinosaurs, large and small, many of them small, did not make it past the mass extinction that happened at the end of the Cretaceous. The period that followed this extinction, the Paleogene, saw life expanded and branched out, but this time with an explosion of mammals as the dominant land animals. They were dominant in the sense that they generally came out on top of the food chains, but also dominant in terms of number and presence all around the world in a variety of different environments. As you know, mammals feed their young with milk produced by mammary glands and have hair or fur. Other characteristics that are less visible include the fact that they have a neocortex, which is a region of the brain, and three middle ear bones, meaning three tiny bones that serve to transmit sounds from the air to the inner ear. All mammals have these characteristics, even though they can take different shapes. The basic mammalian body has four extremities, and most use all for terrestrial locomotion, except humans. We only use two. These extremities can be adapted for life in any and every environment on Earth. At sea, if you think of dolphins, seals, or whales. In trees, if you think of primates. Underground for rodents, or even in the air for bats. The diversity of sizes is also impressive. Mammals range from 1 or 2 inches, like the tiny bumblebee bat, to almost 100 feet for the blue whales. And yet, all mammals apparently share a single ancestor. The modern order of mammals arose during the Paleogene and Neogene, and many species appeared and went extinct during that period. But the appearance of the first mammals is much older than that and emerged from a group called cynodonts. Cynodonts already had a diversity of sizes and positions in the food chain, but they tended to be small for millions of years. And they also tended to be prey rather than predators until non-avian dinosaurs disappeared, opening up an ecological niche for large mammals to replace them. There are several factors that could explain the success of mammals, including their relative intelligence and ability to learn and adapt, as well as their reproductive strategy. Mammals have few babies, but they take care of them, passing on survival skills. Mammals are also very adaptable to different environments. They can regulate their internal temperature, which requires more than food intake, but also allows them to survive in very different climates and to endure dramatic variations in temperature. So, mammals, as a group, had thrived since the Paleogene, and when the Ice Age, the Pleistocene, began, they had mostly reached their modern forms. Apart from a few extinct species of megafauna, the largest mammals, the Ice Age fauna, would have looked very familiar to us. There were apes, lions, wolves, tigers, bears, horses, elephants, all sorts of rodents, whales, dolphins, and the coastal mammals that we still know today. Other orders of mammals were also very similar to what we know today, from birds to fish to insects. So let's take a look at the mammals that did go extinct, starting with what is probably the most iconic, the mammoth. It turns out that a mammoth is not a single species. There were various species which formed a genus. And in the classification of living beings, a genus ranks above individual species. This genus, mammoth, belongs to a broader family called Elephantidae, a family that includes elephants. So mammoths and elephants were relatively close cousins. The degree of separation between them was not that big, and Elephantidae are all large terrestrial animals with a snout that has evolved into a trunk and teeth that developed into tusks. Most known species of Elephantidae went extinct thousands of years ago, and there are only two left nowadays: African and Asian elephants. Mammoths appeared around 5 million years ago, and like their cousins, were herbivorous, eating only plants. Various species of mammoths populated a large part of the earth: Africa, Asia, Europe, and North America, though, as far as we know, not Australia or South America, which were separated from the other continents by large bodies of water. The oldest known representative of this genus of mammals appeared in what is now southern and eastern Africa, a warm region at the time. The descendants of this species moved north and continued to propagate in every direction, covering most of Eurasia. And around 1.5 to 1.3 million years ago, they crossed to North America. Mammoths could reach impressive sizes and weights. Exceptionally large males could exceed 13 tons, or 26,000 pounds, but most of the time they were about the size of modern elephants, though they probably tended to have more hair than elephants. This is not by any means guaranteed or confirmed for all mammoth species because preserved soft tissue has rarely been found, but what is established is that they had much larger tusks and a different body shape, with humped backs and a different forehead. There were also internal differences. Mammoths are generally pictured with a thick furry coat and long hair because of a single particular species, the woolly mammoth, which first appeared 400,000 years ago. It was a late species and is rather well known thanks to the discovery of well-preserved specimens in the area where it lived in Siberia and North America. Woolly mammoths are about the size of an African elephant, so that's pretty big, and they were adapted to life on cold steppes and tundra, where they fed on grass and ferns. Woolly mammoths were probably the last species of mammoths to go extinct, only about 4,000 to 5,000 years ago. But the main cause of their extinction is a bit uncertain. They were hunted by prehistoric men, and this probably at least contributed to their decline. But they also suffered a big reduction of their habitat starting 40,000 years ago due to new glaciation. Woolly mammoths were adapted to life in cold regions, but not icy regions, and since they needed to ingest large quantities of grass, the advance of the glaciers and permafrost at the surface deprived them of a vital food source, though mammoth hunting was certainly a factor too. Woolly mammoths lived in herds, could reach 60 years of age, and did not reproduce very fast, somewhat like elephants today. So, in a region where they were hunted intensively by prehistoric men, their population could have quickly declined and even disappeared. These large mammals were a source of meat, food, and bones to make tools, and one mammoth could probably feed a group for weeks, so they were very attractive prey. A relative of the mammoth that lived in North America was the mastodon, which could be mistaken for the mammoth. A common species of mammoth in North America was the Columbian mammoth, which ranged from the northern United States to Central America, and north of its territories in the Arctic regions of Canada lived the woolly mammoth. The Columbian mammoth disappeared 11 to 12,000 years ago, and here again hunting is suspected to have played a role because, for about 1,000 years, these mammoths coexisted with humans in North America. But mastodons were neither mammoths nor elephants, but they were instead distant cousins. They diverged from a common ancestor around 27 million years ago, and from there, mastodons evolved separately, though they still very much resemble the modern elephant. It is believed that mastodons lived in herds and were forest-dwelling animals. An argument in favor of this is that they had very different teeth from elephants and mammoths. Theirs were cusp-shaped, like human molars, and seemed well suited for chewing the leaves and branches of trees and shrubs. We don't know whether mastodons were very hairy or not. They are often depicted with a thick coat of hair like woolly mammoths, but mastodon remains have also been found in Florida and central Mexico, and though during the Pleistocene these regions were colder than they are today, they were still not freezing cold. So it seems unlikely that mastodons living in those warmer climates would have had a heavy coat of hair. Like the Columbian mammoth, the mastodon went extinct at the end of the Ice Age, possibly due to a combination of climate change and hunting. The extinction of many species of megafauna, these large herbivorous mammals like mammoths and mastodons, represent the dividing line between the Pleistocene and our epoch, the Holocene. But there were other giant terrestrial mammals that disappeared at the same time, including another genus belonging to this megafauna was the Procoptodon. This one takes us to Australia. The Procoptodon is the largest marsupial that ever existed. A marsupial is a member of a subclass of mammals that includes opossums, kangaroos, koalas, and others. Their distinctive characteristic is that they carry their young in a pouch. Due to geography and being surrounded by water, preventing species from migrating everywhere, marsupials are native to Australia, some Indonesian islands, and the Americas. They have more recently been introduced to other regions, like in New Zealand in the 19th century, but their presence in these places is due solely to human intervention. So, in the particular ecosystems of Australia that were separated from the rest of the world, marsupials thrived during the Ice Age, and their biggest representative was the Procoptodon. The largest specimens found were estimated to be 530 pounds or 240 kilograms, and they could have stood up to 6 or 7 feet tall. From 1.6 million to 44,000 years ago, they were the biggest mammals in Australia, and they could have looked like giant wombats. It is believed that Procoptodons lived in open forests and grasslands, feeding on leaves, grass, and roots, and possibly organized around a social structure that is often observed along mammals of large size. For example, with elephants, females and the young form families, whereas males leave these groups when they become adults to live alone, and they regularly fight for the right to mate, with not one, but with all the females of the family. The genus Procoptodon went extinct about the same time that humans arrived. So here again, there is no proof of this, but it is suspected that Procoptodons fell prey to hunting. They were herbivorous, possibly peaceful animals that would have been tempting prey for prehistoric humans. Another well-known big mammal from the Ice Age is the Smilodon, better known as the saber-toothed cat or saber-toothed tiger. It seems, based on fossil records, that it appeared in North America, but thanks to a land bridge with South America, it also spread southward. The biggest specimens, because Smilodon is a genus with different species, were found in South America, where they could have reached sizes up to 500 to 1,000 pounds. Smaller Smilodons look like big modern tigers, minus the color of their fur, which we have no way of identifying. But what made them most visibly different from tigers was their overdeveloped canine teeth, from which they derived their nickname, saber-tooth. Their jaws had a bigger gap between the molars and the canines than any modern cat, but their canines were probably rather fragile and adapted to precision killing. Smilodon must have been a formidable predator and is believed to have hunted bison and camels that lived in the forests or mountains of North America. It is speculated that they hunted in forests and brush rather than plains, because its characteristics seem to call for ambush hunting. But this is just a guess. We also don't know if Smilodons lived in groups or alone. Like all the animals we discussed previously, the genus Smilodon did not survive the end of the Pleistocene 12,000 years ago. It was probably not hunted by humans, but the large prey it fed on could have disappeared, and competition with other species like wolves or humans could have been a cause, as well as climate change. Almost all around the world, the rise of wolves during the Ice Age created formidable competition for other predators. Individually, wolves were not as strong as smaller cats or bears, but their numbers, their social organization, collaboration, and adaptability made them very efficient predators, and certainly the main rivals of humans to dominate the continents. Humans, the genus Homo, alongside wolves, rose to dominance during and after the Ice Age. Our species, Homo sapiens, is the last remaining species. But to be clear, our family tree is not done growing and is still subject to revision. In the past few decades, there have been lots of discoveries that revealed many more branches and subspecies than previously thought. Some are well documented by bones and other remains, while others are more speculative. The timeline and geography of the expansion of the various species of Homo out of Africa is also uncertain. So I'll focus on what scientists agree upon because it is backed by plenty of evidence. But still bear in mind that these are theories, and they are subject to possible changes in the future. In the late 19th century, the theory emerged that humans descended from apes, that they were just a species subject to evolution like any other. At first, this was a very controversial idea, and it was scandalous because it went against many religious teachings. and a very human-centric vision of our planet's history. The idea of an evolution from apes to humans seemed radical at the time and was considered to have little credibility due to the difference in appearance, skeleton, and cognitive abilities between known apes like chimpanzees and human beings. This was simply too much. So another hypothesis was formulated, the hypothesis of a missing link, an undiscovered or extinct species that would have represented an intermediate stage of evolution. But modern scholars have left all of this behind, and with the help of the discovery of more human remains, of DNA testing, and other means of investigation like carbon dating, the current position is not that humans descended from apes, but that we are related by a common ancestor. Humans and apes are part of the same family, and if we go up in the evolutionary tree, all are part of a branch called Hominidae, a family of primates. Millions of years ago, Hominidae branched out into two subfamilies. One branch is Pongini, also known as Asian Hominides, because the last existing genus of this family is orangutans, and they lived in South Asia. But representation of Pongini also used to be present in various parts of Eurasia during the Pleistocene. Another subfamily of Hominidae is Hominini with an N instead of a D, a subfamily that also split into various branches. Gorillini, including gorillas, Pan, which includes apes like chimpanzees, and bonobos, and Homo, our genus. That makes Homo a cousin branch to apes, not its descendant. The question that remains unanswered at this point is who was their last common ancestor, and when did they live? The divergence could have happened as early as 13 million years ago, long before the Ice Age. Hybridization, the possibility of cross-species reproduction, may have been going on for a very long time, possibly as recently as 4 million years ago. In any case, the Pleistocene began 2.5 million years ago. The divergence between the genus Pan, apes, and another genus called Australopithecus had already taken place. You've likely heard of Lucy, the name given to the remains of an individual discovered in Ethiopia. Lucy has been dated to about 3.2 million years ago. She was a female representative of a species of Australopithecus called Australopithecus afarensis. It is from the species Australopithecus that the genus Homo would have emerged, but the exact species of Australopithecus is unknown. There are several possible candidates from being our missing link, so Lucy may or may not be our ancestor. But even if she wasn't, she was at least close to our ancestor. Another uncertainty is the precise delineation of Homo and Australopithecus, which has become more contentious in the past few years. Historically, the advent of Homo was established with the first use of stone tools, which was thought to have happened around 2 to 2.5 million years ago, early in the Ice Age. This, at least, was the consensus in the 1980s, but more recent discoveries suggest that some species of Australopithecus may have used stone tools earlier, more than 3 million years ago, and this discovery blurs the distinction between Australopithecus and Homo. Another accepted theory that is now being challenged is the succession of different species of Homo, leading to our species, Homo sapiens, with two main links. Homo habilis, known to have used tools, followed by Homo erectus. 30 years ago, the mainstream belief was that Homo habilis was the first representative, the first species of the genus Homo, that Homo erectus had evolved from Homo habilis, and that Homo sapiens had evolved from Homo erectus. But subsequent evidence has surfaced suggesting that Homo habilis and Homo erectus coexisted for a very long time, that Homo erectus did not necessarily descend from Homo habilis, and that actually multiple species had appeared and gone extinct between Homo erectus and Homo sapiens, like Homo antecessor, Homo floresiensis, the Java man, the Peking man, etc. All of this has turned the family tree of the hominids into a bit of a mess. Right now, all these discoveries are stimulating, and they reveal a profusion of species, but they also leave us with many more unanswered questions. There are currently a lot of unresolved disputes in the field of paleoanthropology. But let's leave that aside and instead take a look at established species from archaic humans and what we know of them, including Homo habilis, Homo erectus, Neanderthals, and finally, Homo sapiens. Homo habilis first appeared and lived in South and East Africa, a region that is considered to be the cradle of humanity, because this is where multiple species of Australopithecus and Homo arose. Until the 1980s, Homo habilis was considered human. But as I said earlier, this delineation is now contested, and some experts would fold Homo habilis into Australopithecus. It is still fine to refer to them as archaic humans in any case because they certainly do exhibit characteristics that we recognize as signs of humanity. They used tools, mainly for butchering, and it is believed they formed societies of a few dozen individuals. There has been much speculation about all the organization of their societies and the assignment of gender roles between males and females. But the truth is, there is not enough evidence to form any conclusions. What we know better is how they appeared. They were relatively small, around 3 to 5 feet depending on the individual. Males were taller. They were also relatively frail compared to us, weighing only about 45 to 80 pounds. They consumed meat, which probably made up a big part of their diet, and it is believed that a large percentage of this meat came from scavenging rather than hunting. These early humans also ate fruit. We know this because measuring dental erosion on specimens reveals regular exposure to acidity. They could have spent time in trees, which is deduced from their proportions. They had long arms relative to body size and hand bones that could have permitted precision gripping. Homo habilis could probably stand upright for a while and run, but that was certainly not their usual posture based on their anatomy. Instead, it is speculated that they alternated between standing upright and moving around on all fours. Trees could have been a good environment for them, providing shelter and safety from the threat of predators. There is no evidence to suggest that Homo habilis used fire in any sort of controlled way, but there are potential signs of an early form of architecture. In 1962, the circle of stones, dated to 1.7 million years ago, was discovered in Africa, wherein rocks were piled up to 6 to 9 inches high at regular intervals, and these rock piles could have been used to support poles stuck into the ground, maybe to support a rough hut or a windbreak or for another use. But the structure is man-made and as such is considered the oldest claimed evidence of architecture in the world. However, a big question mark remains as to whether Homo habilis built it or if it was constructed by another species, because Homo habilis coexisted with others. There was Homo erectus, which we will talk about in a moment, or even Homo ergaster, an African subspecies that could have been part of Homo erectus, but which is unresolved. There is also Homo rudolfensis, another speculative species. It has been argued that the specimen could just be those of Homo habilis males because they were bigger, or the remains of Paranthropus, a late species of Australopithecus, at the time of Homo habilis. At least at the beginning, it seems Africa was the only continent where the genus lived. This changed with Homo erectus, literally upright man. Homo erectus appeared about 2 million years ago, not long after Homo habilis, and there is no doubt that this species migrated out of Africa, as plenty of remains have been found in Asia and Europe. It is unclear whether Homo erectus evolved from Homo habilis, or if they shared a common ancestor. But what we do know is that these archaic humans began to resemble us more than their predecessors. They had a flat face, a prominent nose, and possibly sparse body hair. Homo erectus was the first known human to become an apex predator. Of course, individuals could fall prey to other predators, but overall, this species rose to the top of the food chain wherever they lived. They were active hunters and able to hunt in groups. They also cared for their injured or sick group members, a characteristic that has not been proven among previous species. And Homo erectus used fire. Individuals were, on average, taller than Homo habilis, with a size closer to Homo sapiens, and weighed 88 to 150 pounds. We only have bones to study, but it is postulated that they would have communicated with a basic proto-language made of modulated sounds. The region where Homo erectus first appeared is unknown, but it has been found in Africa, Europe, and Asia. The earliest remains were found in South Africa, and a few thousand years later in China, and this lends itself to various theories. One is that Homo erectus evolved in Africa and expanded from there. Another is that it appeared in West Asia and the Middle East before dispersing in every direction to East Asia, back to Africa, and even to Spain in the West. In any case, different subspecies have been found that illustrate the range of success of Homo erectus, well-known discoveries whose names you may have heard before, such as Java man, Homo georgicus, Peking man, and Tautavel man, are generally considered part of the Homo erectus species or subspecies. However, there is an ongoing debate whether Homo erectus was a wide-ranging polymorphous species, which would simplify things a lot, or whether all these subspecies, or some of them at least, should be considered independent of one another. Still, these are collectively the dominant representatives of Homo for almost 2 million years, as the extinction of Homo erectus is dated to 100,000 to 110,000 years ago. This early example of architecture, the one I mentioned before, the stone circle found in Africa, could also well be the work of Homo erectus, given what we know of Homo erectus's increased cognitive abilities. There are, in any case, other sites with construction in various parts of Europe, Africa, and Asia that confirm that Homo erectus could build and that this species also developed the use of cave habitation. We see evidence of cave use multiplying beginning about 600,000 years ago, which indicates plenty of Homo erectus groups adopted this form of shelter. Homo erectus gave way to a new species called Homo Heidelbergensis, which for a long time was considered a subspecies of Homo erectus. But Homo heidelbergensis is now increasingly considered to be its own species that evolved from an African form of Homo erectus, because there is strong evidence that Homo heidelbergensis is the common ancestor to two new species, Neanderthals or Homo Neanderthalensis, and us, Homo sapiens. Homo heidelbergensis is characterized by more complex tools and by the use of fire in everyday life. For example, with this species appears hafting technology, which is the attachment of a bone or rock artifact to a handle or strap to make, for example, a spear or an axe. This aligns with the emergence of Homo heidelbergensis, and signs of the technology's presence has been observed in Africa and in Europe. At a time, and this is still disputed, Neanderthals and Homo sapiens would have evolved from Homo heidelbergensis. Neanderthals appeared first, maybe as early as 800,000 years ago, but the oldest remains have been dated to 300 to 400,000 years ago. Neanderthals appeared and lived in Eurasia based on known remains and lasted until about 40,000 years ago. There is an ongoing debate here again about why they went extinct and if they actually disappeared, because they had a relatively small population and they could have been bred into extinction or assimilated by Homo sapiens. In any case, modern humans still carry Neanderthals' genome in various proportions depending on their region of origin. Bear in mind that in these waves of ancient human migration out of Africa and maybe back again, various species coexisted at the same time and could have reproduced. There were waves of species, but also a lot of mixing. Now, in popular culture, Neanderthals remain attached to the image of the unevolved caveman archetype. But when they first appear, they were the most evolved human species in terms of cognitive abilities. and in many ways were probably not very different from Homo sapiens. Their technology was sophisticated, way more so than Homo erectus and Homo Heidelbergensis. To give you examples, Neanderthals could make fire, not just sustain it. They built homes in caves. They made simple clothes similar to blankets or ponchos. They could also weave. They had different cooking techniques, including roasting, boiling, or smoking. They knew some medicinal plants. They went seafaring on the Mediterranean, and maybe another evolutionary quality that makes them like us is the possible development of symbolic thought among them. This is still very controversial because it is unclear whether these attributes can be attributed to Neanderthals. However, a number of discoveries hint that maybe they made ornaments with feathers or shells, and possibly even music. They might have collected unusual objects like crystals or fossils, although this also remains uncertain. In any case, their brain size was in the range of modern humans, and their anatomy had only limited differences compared to ours, such as a more elongated skull, for reasons that are not precisely known. They never formed a large population, only small groups, and this could be the reason for their absorption by Homo sapiens. While Neanderthal populations were spreading to Europe and Asia, a new species was appearing in Africa, Homo sapiens. As a species, Neanderthals probably evolved somewhere between Europe and Asia, and as we have seen before, could have appeared out of Africa. But modern humans appeared in East Africa, near the cradle of Australopithecus and of many iterations of hominids. This would have happened around 300,000 years ago, later than Neanderthals. But since they had common ancestors, the two species were generally compatible for reproduction. Of course, you can just look in the mirror to know what Homo sapiens looks like. This is what we all are. But what distinguished Homo sapiens from archaic humans was our cognitive and social abilities, not just technical, but also behavioral skills. At a time estimated to be 160 to 170,000 years ago, Homo sapiens began to exhibit what paleoanthropologists call behavioral modernity. This is a term created to name a series of traits that distinguish Homo sapiens from other, more ancient humans. These traits include abstract thinking, the ability to plan for long periods of time, symbolic behaviors such as the production of ornamentation and art, and expression through music and dance, traits that are not directly necessary for survival. Homo sapiens also achieved more advanced technological breakthroughs, like the use of blades, for example. The first generations of Homo sapiens lived in East Africa, and from there they spread with such a success that they ended up occupying all continents and major islands of the world. They spread in several waves, replacing or absorbing all other human groups in the process, first to South Africa, then West Africa, the Middle East, and Asia. 65,000 years ago. They were in India and shortly after in Australia, Europe, and China before crossing to North America via northern routes and then all the way to South America. By the end of the Ice Age, some 12,000 years ago, humans had taken possession of the Earth. The last glaciation was ending. The climate was changing, and the flora and fauna transformed the Earth into one recognizable by modern humans. Prehistory would soon end. Countless inventions would follow. At some point, thousands of years later, metals would replace stone, ending the Stone Age. Human societies would develop elaborate and complex systems of thought. They would build fire, fight, create, and exploit the planet and each other. The time for the beginning of recorded human history was nearing, but that is a story for another time. We've come to the end of our little journey tonight. I hope you enjoyed this adventure, and I invite you to discover and learn more. Now you can let go and sleep, or you can pick another story from my library. And until we meet again, good night. Sleep well.